Hello everybody. In our previous videos we have studied about finding the areas of plane figures. We have also studied finding the volumes of plane figures as well as a combination of solids. Now in this lesson we will study the conversion of solid from one shape to another. So welcome to the lesson. I am sure you would have seen candles. Generally they are in the shape of a cylinder. You may have also seen some candles shaped like an animal, as you see in figure 13.17. How are they made? If you want a candle of any special shape, you will have to heat the wax in a metal container till it becomes completely liquid. Then you will have to pour it into another container which has the special shape that you want. For example, take a candle in the shape of a solid cylinder. Melt it and pour whole of the molten wax into another container shaped like a rabbit. On cooling, you will obtain a candle in the shape of the rabbit. The volume of the new candle will be the same as the volume of the earlier candle. This is what we have to remember when we come across objects which are converted from one shape to another, or when a liquid which originally filled one container of a particular shape is poured into another container of a different shape or size, as you can see in figure 13.18. To understand what has been discussed, let us consider some examples. Let's try this. A cone of height 24 cm and radius of base 6 cm is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. So let's roughly represent the diagram. So you have a cone over here. The radius of the cone is given as 6 centimeters and the height of the cone is given as 24 centimeters. Now the child wants to reshape this cone into in the form of a sphere. Sphere is like a ball. The question is, find the radius of the sphere. Now we know that when a toy or any solid is changed from one shape to the other, the volume remains the same. So what is the volume of the cone? It is 1/3 pi r squared h. What is the volume of the sphere? Do you remember the formulas? It's 4/3 pi r cube. So since the volumes remain the same, the volume of the cone will be equal to the volume of the sphere. So let's equate them, substitute the variables and find the radius of the sphere. So let's try that out. So volume of the sphere is 4/3 pi r cube equal to the volume of the cone, which is 1/3 times pi times the radius of the cone, which is 6. So 6 times 6 times the height of the cone, which is 24. Simplify. Pi cancels with pi. 3 cancels with 3. And of course, this is basic algebra simplification. So what do you get? R cube will be equal to 3 times 3 times 24, which is nothing but 3 cube times 2 cube, because 24 can also be split. So we have R is equal to 3 times 2, taking cube roots on both sides. So if you take cube root on both sides, 3 cube will be 3, cube root of 3 cube is going to be 3, cube root of 2 cube is going to be 2. So R, the radius of the sphere, is going to be 6 centimeters. Great. Very simple problem. Let's try this problem. Selvi's house has an overhead tank in the shape of a cylinder. There is an overhead tank in the shape of a cylinder. Let's just draw a rough figure to understand the problem. This is filled by pumping water from a sump which is in the shape of a cuboid. So we have a tank in this underground tank that is in the shape of a cuboid, something like this. The sump has dimensions of 1.57 meters times 1.44 times 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. So initially the sump was full of water. Then the water has been pumped into the overhead tank. After the water being pumped into the overhead tank, there is some amount of water that is still left in the sump. The question is asking us to find the height of the water left in the sump. So what is the understanding of the problem? The volume of water that will be filled in the overhead tank will be equal to the volume of the water that was initially full. When you subtract that with the volume of the water in the overhead tank, you will get the volume of the water left in the sump. So let's go ahead with that idea and solve the problems. The volume of water in the overhead tank equals the volume of water removed from the sump. That's easily understandable. So let's find the volume of water in the overhead tank. Volume of water in the overhead tank. That is nothing but in the shape of a cylinder. So volume of a cylinder is pi r squared h. So now we can easily plug it in. So pi is 3.14 times the radius is 60 centimeters, that's going to be 0.6 meters, times the height is 95 centimeter, that's going to be 0.95 meter. So the total volume meter cube. Now let's find the volume of the water in the sump when it is full. So the volume of water when the sump is full. That is nothing but the volume of the cuboid, which is length times breadth times height. And that is 1.57 minus 1.44 times 0.95. You need to be careful with the units given in the question. The 95 centimeter that is given as the height of the cuboid have to be changed to 0.95 meters. So now the volume of the water left in the sump after filling the tank will be volume of the sump when it is full minus the volume of the overhead tank. Take these two, subtract them, and when you subtract them you get 1.57 times 0.6 times 0.6 times 0.95 times 2 meter cube. This is the result of the subtraction that you get. Now we can easily find out the height of the water left in the sump. If you observe, the water left in the sump is again in the shape of a cuboid. So we will do the calculation here once again. So volume of water left in the sump is nothing but the shape of the cuboid, length times breadth times height. So the height will be equal to volume of water left in the sump, which we found out to be 1.57 times 0.6 times 0.6 times 0.95 times 2 divided by the length times width of the sump, which is 1.57 times 1.44. Now if you do the simplification, you land up with 0.475 meters. Change it to centimeters, 47.5 centimeter. So the height of the water left in the sump is 47.5 centimeters. We need to also find out what is the difference in what is the capacity. The question in the compare the capacity of the tank with that of the sump. So capacity of the tank divided by the capacity of the sump. So we have to find out capacity of the tank divided by capacity of the sump. And what is the capacity of the tank? Nothing but the volume. So 3.14 times 0.6 times 0.6 times 0.95. And what is the capacity of the sump? The volume of the sump. 1.57 times 1.44 times 0.95. Simplify that and you get half. So the capacity of the tank is half the capacity of the sump. That is the answer for what the question was asking. So great, a lot of multiplication and division of our lower grades. The only thing, the formulas were the volume of the cuboid, volume of a cylinder. The rest is nothing but arithmetic and algebra of our lower grades. So do it carefully and get the answer right. Let's try this. A copper rod of diameter 1 centimeter and length 8 centimeter is drawn into a wire of length 18 meter of uniform thickness. Find the thickness of the wire. We know that the shape of the rod is going to be that of a cylinder. So the volume of the rod, what is the formula of the volume of a cylinder? It's pi r squared h. And the diameter of the rod is 1 centimeter. So the radius is going to be half centimeter. So let's figure that out first. So the volume of the rod is going to be pi r squared h, and that is going to be pi times the radius is half because the diameter is 1 centimeter. So half squared times the height, the length of the rod, 8. So that's going to be equal to 2 pi centimeter cube. So now we know what is the volume of the rod. Now the length of the new wire of the same volume is given as 18 meters. The length of the wire is 18 meters. Let us change this into centimeters. It's going to be 1800 centimeters. So if R is the radius of the cross section of the wire, if this is the wire we have, and if R happens to be the radius of the cross section of the wire, again the wire is in the form of a cylinder. So the volume of that wire is going to be pi r squared h, and the height is 1800 centimeters. So the volume of the wire is also going to be pi r squared h, and that happens to be 1800 centimeters. And the two volumes are going to be the same. So let's equate them now. So pi r squared times 1800 is going to be equal to the volume of the rod, which is 2 pi. Simplify that. R squared is going to be equal to 1 over 900, and R is going to be equal to 1 over 30. So the diameter of the cross section or the thickness of the wire is going to be, diameter is going to be 1 over 15 multiplied by 2, because the diameter is 2 times the radius, centimeters. And that's going to be approximately, if you have to change it into meters, 0.67 mm. If you want to change it to millimeters, it's going to be 0.67 mm. So great, you need to remember the formulas, find out the variables that are given, apply it in the formulas, equate the two volumes, and follow the simplification process. Let's try this. a hemispherical tank full of water is emptied by a pipe at the rate of 3/4/7 liters per second. So every second 3/4/7 liters is emptied. How much time will it take to empty half the tank if it is 3 meters in diameter? So this is pretty simple. What is the radius of the hemispherical tank? Radius R of the hemispherical tank is, the diameter is 3, so obviously it's 3/2 meters. Now what is the volume of the full tank? Volume of the tank, since it's a hemispherical tank, what is the formula to find the volume of a hemisphere? 2/3 pi r cube, and that's going to be 2/3 times 22/7 times 3/2 cube, which is going to be 99/14 meter cube. So the volume of the water to be emptied, we are only emptying half. This is the volume of the full tank. So the volume of the water that has to be emptied, to empty it, is going to be equal to half of the volume of the full tank, 99/14 meter cube, and that's going to be, simplify 99/28, change it to liters, 1000 liters, which is going to be 99,000/28 liters. This will be the volume of half of the water that has to be emptied. Now since the question says 3/4/7 liters per second is emptied, that means if I change it into an improper fraction, 25/7 liters per second. Now since 25/7 liters of water is emptied in 1 second, 25/7 liters of water is emptied in 1 second, how much time will it take to empty 99,000/28 liters of water? We have learned these kind of problems, cross multiplication. So that's going to be 99,000/28 divided by 25/7. When you flip the division, it becomes 7/25 seconds. Simplify that, and that's going to be equal to 16.5 minutes. So the time taken will be 16.5 minutes. Excellent. You need to remember the formula to find the volume of the hemisphere. Then plug in the variables. This lesson basically requires some understanding, conceptual understanding, the formulas, and then a lot of multiplication and division. Thank you for watching this lesson, and please do share and subscribe to this channel, Wisdom Outlined. Thank you.